Okay, today, go, out of the way. So today, we're going to be dealing with, the trig functions today. We're actually moving on to section 4.2 and 4.3 today. These are the sections, we are messing with two sections back to back, just because they're dealing with the trig functions in general, and I want to make sure that we know what we're doing here. So, trigonometric functions. Okay, now the good news is, trigonometry is the study of right triangles. We've talked about right triangles quite a bit in geometry. We talked about right triangles a little bit in Algebra 2. But I want to talk about what we're going to be using them for the first part and what it's going to eventually mold into today. So, let's start with the actual trig functions themselves. There's 6 main functions we need to know. So we're going to go through the names today. We're going to go through how to draw them and how to use them today. Okay? Alright. So the main part here on the main names of your trig functions. And this will be probably one of the few days to actually write out the full names. Sine.
Cosine.
Cosine.
Tangent.
Tangent.
Invert sine. Inverse sine. Inverse cosine. Inverse tangent.
Which is called
Are you going off on a tangent right now?
cosecant. Secant. And cotangent. These are the actual correct names that you're going to see. Now, they have abbreviations.
Why'd you write them in a different order?
For the pairs. Okay? The goal today is to focus on the top 3. That's the goal today. The goal tomorrow is to focus on the bottom 3. How to type in your calculator, how to figure out, how to find solutions for them. Do we feel comfortable with it? Okay, does that make sense?
Yes.
Okay. So now, let's walk through this. So, the big thing about the main 3, because that's what we're focused on today, is this little acronym. SOHCAHTOA. You do need to know what SOHCAHTOA stands for. It's this little abbreviation that I use to help me remember the formula for the trig functions. Now, the trig functions, in the first place, they only deal with right triangles. That's it. Right triangles only. Okay, so I'm going to give you the formulas for the first couple. Maybe I'll start with sine and we'll kind of work our way through it. And then I'm going to show you how they relate with the picture, and then we'll do an example of it. Okay, so let's start with the first one. So the capital letters here, these are the trig functions. Okay, that's what the capital letters are. So S, C, and T. Sine, cosine, tangent. The lowercase letters at the back, those are the walls of your right triangle. So we'll label those as we go. But the first one stands for sine. So the abbreviation for sine is SIN. That's the abbreviation we use. Cosine is COS, and tangent we use TAN. Those are the main 3. So you'll see those buttons on your calculator as we go through it today. The bottom 3 that we'll see tomorrow, they have a different abbreviation. They have CSC, SEC, and COT. Now, the problem is, these 3 are not on your calculator. They're not. They're not the tangent -1 or cosine -1 or sine -1. Okay, but for the sine function, what this button is on your calculator, when you type in sine, they're expecting you to type an angle after it. So when you hit that little sine button, it's especially on a menu-driven calculator, something like this. That's a menu-driven, you can see exactly what you're typing. Yeah, so it's waiting for an angle after it. Okay, so we'll type in an angle here in a minute. Then the letters after it, the O and H. The O stands for opposite, and H stands for hypotenuse. Now, on a right triangle, hopefully this makes sense to you what those letters are. So for instance, on a right triangle, theta is just one of the angles other than the right angle. So it's got to be one of the acute angles. Remember, on a right triangle, the other 2 angles are acute, they're small. So if I put theta down here, then what we can do is we can label the opposite and hypotenuse to where this angle sits. The opposite is always across the picture. The opposite wall where your angle sits. So if your angle is up here, the opposite wall would be the one on the bottom. Okay, the adjacent wall is the wall next to your angle. Adjacent means next to or touching. And then the hypotenuse is always the biggest wall. The hypotenuse of a right triangle is always the wall that is not touching the right angle. These 2 are actually called the legs. That's the hypotenuse. It's the biggest wall. Okay. So on this particular trig function, we're using the opposite wall, the wall across from your angle, and we're using the hypotenuse. So what your calculator does for you when you type these in your calculator, like let's say you typed in sine of 30 on your calculator, right? You typed in sine of 30. Well, the idea of what it does is that it's automatically pre-programmed to know what the walls are on a triangle, like the ratios of the walls, and it takes whatever the opposite wall is and divides by the hypotenuse. And so when it automatically does that, it automatically spit out half or 0.5 on your screen. Okay? Now the reason being, and you're probably thinking, well, I can draw any triangle. How does it know which one it is? Because it doesn't matter. Whatever the opposite wall is, it's in relationship to the hypotenuse, where the opposite wall is always going to be the 1 unit length. The hypotenuse will always be twice as long, and it will always divide and it will simplify the fraction. Okay? When it simplifies the fraction, it will always turn out to be half. It's just the way that the triangles are set. When you have an angle, the walls are already preset. Like they already know what the ratios of the walls are. And that's why it's useful. That's why having that scientific calculator or graphing calculator, they have them pre-programmed. So now, if the calculator already knows what the walls are supposed to be, you can use that to find what the walls are. You can kind of reverse engineer the problem, which is kind of fun. Okay, so that's what we're doing today. We're going to be looking at like how to use this calculator, how to use this like weird decimal it's giving you to actually find the wall lengths. All right, does that make sense for sine? Okay, now we'll get to that. I'll explain this whole 30 degrees idea. We'll do an example so you can actually see like how to use it, how to type it in your calculator. Especially because like everyone in this room usually has a different type. Looks like for the most part everyone's got the same style. I'm worried about that little, is that a Casio?
Yeah.
I think, can you just type in everything and then hit enter? Or does it? Oh yeah, it'll be fine. So it's basically the same as everyone else's. You're going to have to do things a little bit different than everyone else because you don't have a menu driven, but it'll still work. It'll still give you the same answer. So when I start telling how to do stuff, I'll explain to you just very uniquely how to do your problems. Okay. All right. So that's sine function. Now cosine. Let's do that one next. All right, cosine. All right, cosine of your angle. Well, when you look at the letters A and H, those stand for the walls when you're using cosine. So cosine of an angle is the adjacent over hypotenuse. The second letter always goes on the top of the fraction. So that's adjacent. And the third letter will always go on the bottom. So now we're going to be dividing by the hypotenuse here. So that's what the little acronym tells me. So adjacent over hypotenuse. And again, on a right triangle, you'd use whatever the bottom wall is, and you divide by the hypotenuse, and that'd be the fraction that you'd have set up for whatever that angle is. And again, we're going to use these today to find out actual distances. And then the last one is obviously tangent. Tangent of an angle. So what's the fraction I'm going to put after tangent?
Opposite over adjacent.
Yeah, because O over A, so opposite over adjacent. Opposite wall divided by the adjacent wall. Okay, so these are my 3 formulas for the main trig functions. And what we're going to look at today is how to use this. Like, if I give you a real-life application problem, could we use these to find an angle or find a length? So that's what we're going to be doing the next couple days in here. Which I think is kind of fun. Most part, a lot of you learn this in like geometry for the first time. You see it for the first time. Then in Algebra 2, they kind of perfect it a little bit. And then in Pre-Calc, we really hammer it down until you really know it like backwards and forwards. Okay?
What are the 2 letters after your T up there?
O and A. Sorry, they kind of blend together. Sorry.
Well,
O and A. Toa. SOHCAHTOA.
Yeah, that's what
Yeah, sorry. That's a good question. That's what we got to figure out today. Okay, we good though? All right, let's do an actual example here. Does everyone have the formula set?
Yes.
Okay, so let me explain. I'm going to show you a slide that will hopefully kind of explain what we're going to be doing here, and then I'll show you kind of some funny ways to think about it. Okay? All right. So what we're going to be using these trig functions for is to find the height of an object. So let me give you a slide of what I'm talking about. This will have the definition. So in trigonometry, that's what we're in. It's the study of right triangles. That's really what trigonometry is, the study of right triangles. And it's trying to find the relationship of angles to wall lengths. So the idea is that with a calculator, we can actually find heights of objects using a right triangle. So what this little slide is trying to explain is that you do not need to have direct measures to find it. What I mean by that is like I don't need to climb this mock Eiffel Tower here. So I don't need to climb the mock Eiffel Tower to figure out how tall it is with a direct form of measurement with like a ruler. What I mean by climbing is that, let's call this Bob down here. Bob could guesstimate the height of the Eiffel Tower if he were to climb it. So like if Bob knew his height, maybe he's 5'10" or 6 foot, somewhere in that range. Bob could literally, calculate his height, and we could put the height of the Eiffel Tower in terms of Bob's. Okay, so far the Eiffel Tower is more than 2 Bobs tall. It's now 3 Bobs tall.
Maybe 6 Bobs.
It's now more than 4 Bobs tall. And this is not drawn to scale by any means. The Eiffel Tower is huge. It's more than 5 Bobs tall.
6 Bobs.
It's now more than 6 Bobs tall. It is almost 6.5 Bobs tall. Maybe almost 7 Bobs. Okay, you could do that. That's silly. You could do that in theory. But that's silly. That's what they're saying, that we can get around this without doing direct measurements.
I would definitely do that word, so. Yeah, let's just do that for us.
No, it's silly looking at that. All right, so no, we're not going to put it in terms of Bob's tall. All right, but here's what you can do, okay? You can use the numbers around the actual tower itself to help us out. So here's the idea. You could use what they call an angle of elevation, looking to the top of your object. Now, an angle of elevation could be anywhere. You could stand any distance from the object and look up to the top of it, okay, to find, the angle of elevation. You could use, the shadow on the ground to help you out with where to stand. If you're standing right at the edge of the shadow on the ground of the Eiffel Tower or whatever object you're looking at, the angle of elevation will actually look at the sun. Let's put a quad over here and the sun peeking out. Here's the sun. All right. If you're actually looking at line of sight with the shadow, the line of sight will actually take you directly to where the sun is. That's a line of sight if you're using it like the shadow. But you can stand anywhere. You don't have to use the sun. You could stand where Bob's at and just put, you can put a device on the ground to actually measure the angle to the top. Again, most people's cell phones can do that. Okay? So if you had a cell phone, like an iPhone or an Android phone, they can all measure angles. Okay, you can actually put your device on the ground. You have a compass app. On every iPhone or every Android device, there is a compass app, and it looks like that. It tells you, which direction is north. But when you slide, it'll give you a level on the ground. So when you tap it, it levels it out, and then you can tilt the phone and tell you the angle you're tilting at. So I can put the phone on the ground, hit the screen, so it levels it out, and then angle it, and it's telling me this is roughly about 40 degrees, roughly. Okay. But again, it's not drawn to scale. But again, you could do that with your phone, and it would tell you the angle. But again, this would have to be pointing at the top of the object, so you have to get kind of on the ground and kind of level it out. But that can give you your angle of elevation. Now, the line of sight, again, is going to the top of the object. That's where your phone has to tilt. You need your horizontal distance. That would be probably the number you could control, the horizontal level, the distance to your object. That could be either the shadow, or it could be just how many steps away you are from the object. You can actually make footsteps, to the actual object, or actual strides if you're really consistent. And then you'd have to use this angle, and that can help you find the height of the tower. You actually stand at the spot away from your object where the angle of elevation to the top of the object is exactly 45 degrees, like I showed you earlier. Not just anywhere. Like don't go 30 degrees, don't go 15. Find a spot where your cell phone makes a perfect 45. Because if you're standing at the spot that's exactly 45 degrees to the top, and this is supposed to be a right triangle, then this is a 45 degree angle, and now it's isosceles, according to geometry, where this wall and this wall have to be the same size. So the distance you are standing away from the object is exactly the same as the height going to the top. That's probably the smartest way you can figure out the height. But that means you have to be willing to stand really far away from the object to do that if it's really tall. Because it's going to be the same height as the object if you go to the perfect 45. Now to prove my point, I'm going to do the trig function to show you this. So let's say we didn't know this number. Let's say that's what we're trying to find, the height of this object, and I'll call this x. Okay? And so we're going to use my angles. Now what is this wall called?
Opposite.
Opposite wall, okay? So we're going to use the opposite wall. This is now the adjacent wall. It's the wall next to my angle. And so if we're thinking about SOHCAHTOA, we could find which trig function to use because based on the labels on my picture. So this one's using opposite and adjacent, so which one should we use? TOE. That's one that uses O and A if I wrote it a little bit easier to see. Okay? So I would be using tangent, right? That's what the T stands for. Because it's using tangent of my angle is 45, is the opposite wall, which is X, over the adjacent wall, which is my 324. Then, how do I find X? What's my rule?
Multiply by 324.
Exactly, because it's called an inverse operation, right? If you want to find X is on the top of your fraction, you do the opposite. If they're dividing by 324, you multiply it over. So that's 324 times the tangent of 45. Now, if you're on a calculator like pretty much everyone has in this room, except for Jared here, you can type it in exactly what you see there, and it gives you your answer immediately. Okay? It'll tell you in terms of meters, because that's what we measured in. But that'll be my number. And it should tell you 324 on your screen. It should be the same number. Okay? Now, Jared, for you, since you don't have the menu driven, you have to type it almost backwards what you see. So you have to type in the 45 first, hit the tangent button, and it'll give you a decimal on your screen, right? And then you take it times 324. It should tell you 1, basically. And then when you type it in, it should tell you 324. So you just have to do it backwards. But it'll give you the same results. Questions on how to use your calculator? Did anyone not receive the 324? Okay, so let's say we're trying to find the height of the flagpole, okay? All right, so here's what I want. And this will be kind of the options up to you. We're going to say the angle of elevation to the top of your flagpole is 30 degrees. I don't want to do the 45-degree thing, so I'm going to tell you right now, wherever you're standing away, it has to be 30 degrees. So I'm going to just predict that for you right now. You guys get to pick this number.
724.
So you can pick whatever number you want, okay? I'm going to walk around the room. What I'd like you to try to do is, and again, you get to pick this number. So this is the number you get to make up on your own. I want you to find the height of this flagpole doing the same math we just did. Same math, but you get to pick the distance you are away from that flagpole. My last class, people were picking crazy numbers. That's fine. You can pick whatever number you want. Just make sure you label it, and you have to use 30 degrees, and I want to figure out how tall your flagpole is. Okay? I want to walk around the room. I'm going to take a little camera. I want to see written on paper, like the drawing with your numbers in it, and I want to see that you can type it in front of me to give me what the number is that you just found. Okay, just the same math that we just did. Got it? Okay, and I'm going to take the camera around and I'm going to self-record you. Okay? And you don't even have to talk. I just want to see it. Okay, so Morgan, what was the distance you picked?
938.
That's It's 938. What's the label on it?
What?
Feet, meters, yards, what do you want to do?
I don't know. We're just going with it. We're doing feet.
Feet, okay. You type it in, so what's your number then?
541.5.
Okay, good. Because I agree with that. Because what was your original formula? You had-
938 tangent.
Okay, good.
30.
Yep, good. Okay, Jared, what was your number?
352.
Okay, nice. And then your formula. Okay. And what was your labels and feet?
Feet.
And then how do you type that in for you?
I have to go backwards.
Nice. Good. And you got what was that?
203.
Yeah, that makes sense. That was kind of a good number. Okay, good.
Delete that.
Alright. Type that in. Yep. Excellent. Good. Yours actually can do radicals in your calculator. That's really cool. That can do exact answers. Alright, good.
I'll let you talk.
Okay.
You can't do two things at once. I'm helping.
Alright, and so what's your label on that?
Feet.
Feet. Okay, good. Alright. Okay, so you picked how many feet tall is that? I can't even see.
50.
50 feet? Okay, so you went with 50 feet. That's a Garner water tower?
Yep.
Perfect. Alright, and you picked a 54-degree angle. Now, your number you got was 36, and so we'll see you typed it in. Now, does that number make sense to you?
Yes,
Why?
because this angle is going to be smaller than that angle.
Okay, so it could be a
It's
smaller
going to
number.
be smaller.
Okay, good. Okay. Good. Alright, so you went with a 51 foot.
Yeah, 51 feet, 39
Okay.
degree angle.
And then so that's what you typed in your calculator. Now, does
Yep.
that number make sense to you?
Yeah.
41 feet. Okay.
think,
And,
yeah.
Okay, why?
I don't know because the angle's smaller than 45. I have no idea.
Because you went 39, so she get 51 over here. But this angle's big, right? You said this was gonna be, that was a bigger angle? Shouldn't this be a bigger wall?
Justin, was it 10 centimeters in an inch?
Type in your calculator.
10 centimeters.
Okay. 51.
2.54, but I just did 2.5. I'm not about that
4.
extra decimal type thing.
It's a really bad water tower. Oh my god.
41.
Yep.
In DEG mode. Yeah. Tangent of 39, you want 39 degrees. Okay. 51 feet.
Reese, come here.
I don't know what I did
Hey,
wrong.
we're gonna bring these up.
the same answer.
All right. Okay. So I want some numbers here. So we have a water tower. So here's my crazy water tower. Garner water tower. All right. So
Okay, the wall
Yeah.
is 51,
51 feet. Okay.
and
You'll never see that.
Angle to the top.
the top angle,
This angle.
that angle, 39 degrees.
39. All right. Hey. So. Here's what we have. We have the water tower is 51 feet. We're at a 39 degrees looking up. That's an angle of elevation looking to the top. I want to know how far you're staying away from the object. I think the answer was 41 feet. Okay. I want to discuss why that number doesn't make sense to me. Because I was trying to ask questions. Okay. Yeah, the top angle, what was it? What was the top?
51.
51. Okay, so we said this was going to be 51 degrees. This should be a bigger wall than that. Certainly, right? It should be. She was typing her calculator, and it kept telling her 41 degrees. The reason why, you were typing it wrong. One simple thing. Now, hey, let's talk about it, okay? When you do TOA, right? Because she was doing tangent. Tangent of your angle, tangent of 39 degrees,
Okay, I know now.
is 51, the opposite over adjacent.